Now we will see dependent sources. What is dependent sources? A dependent source is a source whose value is dependent on the voltage or current of any branch of a circuit. In this example, you can see there are three sources. One is here 2 ampere source, another is 3 I0 source, and another is 12 volt source. But out of three sources, two are similar. One is a diamond shaped source. One of the fact about the dependent source is the dependent source is always shown by diamond shape. Here you can see there are four types of dependent sources. First is voltage dependent voltage source. Second, current dependent voltage source, voltage dependent current source, and current dependent current source. We will see how they look like. Here you can see this is a dependent source of 3V0. It is a voltage dependent voltage source. This is a voltage source and it is dependent on the V0, that is voltage of circuit. It may be dependent on any voltage in this problem. It may be a voltage across these 8 ohm resistors like this, plus minus, and this may be V0. It may then here you can see 5I0 is the current dependent voltage source. A current may be from any branch of the circuit. Here is the voltage dependent current source and here is the current dependent current source. Now we will solve a problem on dependent sources. In this problem we have to find V0 and I0 in the circuit. V0 is the voltage across these 8 ohm resistors and I0 is the current flowing through 2 ohm resistor. How we will solve? Let us see. In this example, two sources are given. One is 6 ampere source, it is current source, and another is I0 by 4 source. This is a current dependent current source. So we will use Kirchhoff's current law to solve this example because there are two current sources are given. So it will be easier to find the solution of this problem with Kirchhoff's current law. What is Kirchhoff's current law? It says that at a particular node or junction, the current coming towards the node is equals to current leaving the node. So it will be I1 will equals to I2 plus I3. Similarly, in this example, we will use this Kirchhoff's current law. In this diagram, you can see there is a single node here. Here there is no any resistor connected at this part. Therefore, these all are at same potential. So we can consider this as VA. It is a single node and another node is V0. So now the diagram can be reconstructed as following. I have redrawn this diagram for the sake of simplicity. Now we will consider a node here. Let us give a name VA and this is the single only node in this example. Another node is ground node. Consider it as V0. The voltage of this node is equals to 0 because it is grounded. So we will apply Kirchhoff's current law at this node. Let us say this is the current incoming towards this node. This is the outgoing current. Name it as I1. This is already named I0. This is outgoing current. it has value I0 by 4. It has named I2 and this outgoing current I3. Applying Kirchhoff's current law, we will get this is incoming current towards these nodes, that is I1. There is no another incoming current, will be equals to I0 outgoing current plus I2 plus this I3. So this is the Kirchhoff's current law applied. Now we will use Ohm's law to find the value of these currents. What is that? V equals to IR. So I will be equals to P by R. That is voltage across the resistors and the resistance of the resistors. Here in this branch the current is directly given 6 ampere equals to I0. I0 is the current through these 2 ohm resistors. Therefore potential across these 2 ohm resistors and the resistance of this resistor. It is the potential is VA minus V0 divided by the resistance of this branch 2 plus this current is I0 by 4 plus VA 8. So now we have the value of I0 equals to VA minus V0 divided by 2. That is, as the value of V0 is 0, we can write as VA by 2. So replacing it with this I0, we will get 6 equals to VA by 2. V0 is 0 plus VA by 2. Don't forget that the 4 is in the example. This is divided by 4 plus VA by 8. Solving it, we will get, taking LCM, four VA plus 2 VA will be equals to 6 VA. Therefore, VA will be equals to 48 by 6. VA will be equals to 8 volts. We have found the value of VA. VA is the voltage at this node. So now we have to find V0. V0 is the voltage across this 8 ohm resistor. How we will find? V0 will be equals to the current flowing through this resistor multiplied by the value of this resistance. Current flowing is I3. We have the value of I3. We have written it as VA by 8. VA is the potential drop across this 8 ohm resistor and 8 is the value of this resistance. Solving it, we get V0 equals to VA, that is V0 equals to 8 volts. Now we have to find I0. I0 is the current flowing through this 2 ohm resistor. How will we find? I0 will be equals to the voltage across this 2 ohm resistor divided by the value of this resistance. We have the value of VA, that is 8 volt. Therefore, I0 will be equals to 4 amperes. So we have found the value of voltage and current in the circuit.